Hello everybody, my name is Sonny and I'll be your coach guide for the second part of the video. You already met Steven and Judith, they are my co-workers, and in the first part of this video you saw our office that I haven't been there in like 2 weeks because I'm still in quarantine, right? Staying safe by staying home. Um, you probably saw my desk there, you probably don't know which one it is, but my desk is there, kind of miss it. But for now we're going to be working through our computers in our homes where we're safe. And as we watch this video, I'm going to pause it at some points to further talk about what Steven is talking in the video and give you some assignments for you to do later on. So let's start with the video. Let me start it up real quick and let's listen.
Who is that? It also makes coding, hands down, and I'm not exaggerating, the most complicated form of writing there is. The levels don't even stop at one. Once you are able to write something that writes something else, you know what can happen. That thing that you wrote to write something can write something else, which can write something else, which can write something else. Do we do that? Yeah, we do. A lot.
Right, so he's talking about different levels of writing that at the end like builds something that's bigger than before. Like you start with little things and you keep building and building. I don't know if you tried Scratch yet, but if you did, you notice that one block makes Scratchy the cat spin or move, but as you start combining them, you can make Scratchy dance or say stuff or like play a little game. So it's little pieces of writing that once you start adding to them little by little by little, it'll make a very big program. That's how video games are made. That's how videos, internet pages, websites, anything. That's how it starts.
Get out of here. Go. Inside of Scratch, you can create a program that writes out another programming language, like this one. When I run this piece of writing, I get that piece of writing over there, which has inside of it another place where I can create pieces of writing. It's this little prompt right here. And then when I press enter, that program, written in Scratch, writes out the results for the program I wrote inside of it. In this case, the number 4, because I added 2 plus 2.
Okay, let's pause here real quick. So you probably noticed that the code in Scratch is like very complicated and advanced, but it's not impossible to do it because somebody already did it. So don't put limits on your creativity. So there's a website, Scratch, that's one level. Somebody coded that Scratch program, that's a different level. But then once you run that Scratch program, you can also interact by typing code and then receiving an answer. In this example, he typed in add 2 plus 2, which is some code that the Scratch person that did this made it possible to add it like that. And you get 4. So that's at least 3 languages, the Scratch website, the interface, so a little video game, and then the user typing code to get answers. So that's at least 3. Can you think of other levels? And I think he's going to mention them right now, so let's keep listening.
I wish I could tell you that was the end, but where did Scratch come from? Well, Scratch 3.0 is a language written in JavaScript, which means that the developers of Scratch wrote JavaScript and then they pressed their equivalent of a little green button and out popped Scratch, which you can write other programs with. We could ask, where did JavaScript come from? What writing did the JavaScript programming language come out of? Or we could zoom into one of the levels I skipped and ask, how did the JavaScript code on the Scratch web server produce the code that ends up on your computer, which is actually the one that runs and makes the Scratch user experience?
Okay, so he added more than those three levels plus some more, right? So he mentioned JavaScript, which is the thing that makes the website work. But then in between there's another level where some server that has the code, the source code for the website, is being, you know, added right there. So that's now what, 5. So there's a bunch of more levels, right? So one of the assignments is going to be to make a chain of 10 levels. You can use Scratch as an example, but that at the end, there's 10 levels that start with something and then finish at something else. And at every point, there was some sort of like human interaction or computer compiling, meaning like the computer did some computation or some running some code in order to get the next level. So at least, that's the last 3 levels, which is adding 2 plus 2 and the Scratch video game, having the Scratch video game, having the Scratch website. So that's at least 3. So can you think of 7 more before that, or maybe I'm missing some in between here? Or use another example. If you use some other websites, maybe a video game, maybe something you use for like education software, YouTube videos. How do the YouTube videos get there? Somebody recorded them with a computer that had a webcam, etc., etc. Okay, so at least 10 steps or 10 levels that start with something, and then after 10 steps, it converts into something else. Okay.
Are coders allowed to make a JavaScript program that produces other JavaScript programs and then sends them to your browser? Yeah, they are. They're allowed to do that. Is it complicated and hard to think about? Can be. And I know that can sound scary. How can it ever be possible to understand so many layers of writings that create other writings, that ship other writings to your browser, and then you write inside of some of the writings and it produces other writings that you can then also create writings inside of that creates other writings. That's a lot. I won't.
Yeah, so I don't know if you were able to follow that, but I wasn't, because there was, he was saying there's code on top code and a different level, and then trying to explain how the servers interact with the website. So it's a huge like web of interconnected code that different people wrote and you're allowed to use like that. So it's just a little taste of how everybody is able to contribute some piece of code that get used in some other program, and then that gets fed through other things, and it's just like a web of code. And it can be complicated once you get up to higher levels of interaction, I guess.
Lie. But here's the amazing thing. Those giant, complicated software systems, they can be understood with the simplest form of writing there is. We write our ideas down on paper, and then we code them. How do you write a big, complicated thing into existence? By writing simpler stuff first. It's that simple. How do you write really complicated things across any form of writing? You write simpler kinds of writing first.
Right, so I was saying in the beginning, in order to get some complicated code or like a lot of code to work, you need to start small, right? Now you have this cool idea of this awesome video game that's going to have 10 characters and everybody's going to look different and have different fighting moves or running animations and stuff. But before you can get all that working, you need to start small. You need to start with like one character and first design the character, and then choose like the types of clothes and the armor and maybe weapons, the hairstyle, the eye color, all that. And then once you have the model, you have to now be able to make it move. You need to make the right arm move and the left one, and like put like an attack position or some little dance that they do. So you have to start little by little, and then you have the second character. But maybe you can use stuff that you work for the first one, work for the second one. So it's easier for the second one. And then easier for the third one, so on and so forth. So as whenever you have an idea of something you want to build, you have to start small. And by adding small and small and small chunks of code, it's going to grow into a cool piece of code, right? And I just thought of another assignment. Think of 10 animations needed for a character in a game. One of them could be blinking. You need to sometimes make your characters blink, right? Or maybe the mouth needs to move when they're talking like this. Or their fingers need to move, and their wrists and their hands and their forearms, stuff like that. So think of as many as animations as you can for a character in a video game in order for him or her to look realistic when they're like walking or fighting or whatever. Okay? That's going to be another assignment.
That's how you do it. So if you are trying to learn how to code and you want to take the fast route, start with writing and start with paper. That is where I start with every software project. That is where I start with every piece of writing that I do.
So don't forget to bring paper next time. I know you still have it there.
Get out of here. I'm trying to record something. Can I write a 3D model? Yes. Can I write Can I write using my voice? Yes, of course. I'm doing it right now.
Me too.
Can I write using a webcam and American Sign Language?
Do you know American Sign Language? See you next time.